So good morning students, how are you? Now I hope all of you are very fine. So as you know that today I have to explain which function? Rational function. Okay, and what is the rational function? Previously what do you know about the rational? Rational means you have studied the rational number. Okay, a number which can be written in the form of p upon q, where q never will be equal 0 and p and q are the integers. Okay, so but our today's topic is what? Rational function. I have not to explain rational number, I have to explain here rational function. So let fx is equal, I am taking gx upon hx, where gx is the numerator and hx is in the form of the denominator, where hx never will be equal 0. Okay, so this is the finally the function. Okay, and this function is defined from f such that real number tends to real number. This real number represent what? Domain, and it is codomain. Okay, so students, for this function there is not an exact definite, you can say you have not a definite function, but I will explain here the graph by taking some examples for you. Here fx does not equal to gx upon hx. Okay, where hx does not equal to the 0. Here students, one more thing I want to tell you. I will before the graph I will tell you how will you determine the graph, and also the domain of the function, and after that I will discuss to the range of the function. So let's see here, actually the function for the rational is not decided. You can take here, let fx is equal x upon x minus 2. So students, it is also a rational function. Next I have taken, and suppose I am taking fx is equal x minus 2 upon x square minus 5x plus 6. So students, it is also a rational function. This means the function is not decided. For the modulus function is decided. For the, I have given you the example of integer identity function is also decided, constant function is also decided, but this function is not decided. Okay, so now I'm going to tell you how will you determine the domain of this function. Now students, here one thing you know very well, actually here the domain, here the denominator never will be equal 0. Is it clear? Okay, so now in this function I am talking about what is the domain of this function. What is the domain? This domain is defined for all the real numbers. Okay, we can put all the real numbers, but domain here we know that denominator never will be equal 0, means x minus 2 does not equal 0. Is it clear? So what is the value? So this means x does not equal 2, means for the domain, if you are talking about the domain of this function, all the real numbers, but what cannot be involved? 2 cannot be involved, means we can take all the real numbers, but you cannot take 2. According to the definition of the domain of the function, all the set of values of x for which the function is defined, function are defined for all the values but not for defined for the 2. Actually students, see here, if you put 2 at the place of x, so tell me what you will get. So see here, so fx is equal, that will be x whatever. Suppose if you are putting here, okay, listen, if you are putting 2 at the place of x, so what you will get? It's a 2, x is 2, and now here is 2 minus 2, so this will give you 2 upon 0, and 2 upon 0 is undefined. It is undefined. Is it clear? Okay, so because of this, the function fx is equal x upon x minus 2, and the domain of this function is what? All the real numbers but except 2. Because of the definition of the domains in terms of the function, all the set of values of x defined for the function, all the set of values of x for which the function is defined, here the function is defined for all the values of x but not defined for the x is equal, when x is equal to, the function is not defined, you can say undefined. Okay, because of this the domain of this function is real number minus 2. Okay, so now I will discuss on that another function. So this is over now. I will discuss to you on this function. Here again you can say, for this I am finding here what is the domain of this function. What is the domain? So say here we have here denominator never will be equal 0. So what is denominator? It's x square minus 5x plus 6 does not equal 0. It should be not equal 0 according to the definition of the rational function. Okay, so this is a rational function. We can identify it. Actually it is written in the terms of the gx upon hx. What is gx? X minus 2. What is hx? X square minus 5x plus 6. So x square minus 5x plus 6 does not equal 0. This means if you solve this equation, this quadratic inequation, so this will give you what? X square minus 2x minus 3x plus 6 does not equal 0. So x you can take here the common, so it will give you x minus 2, and minus 3 if you are taking common, so this will give you x minus 2 does not equal 0. Finally what you have? X minus 3 and x minus 2 does not equal 0. So this means what you have? So this means then you can write x minus 3 does not equal 0 and x minus 2 does not equal 0. So the values are what? So x does not equal 3 and x does not equal 2. Okay, so what is the domain of this function? What is the domain of this function? So domain is what? Domain is all the real numbers, but not 2 and not 3. Okay, because of this. Okay, so in this way you can find out. If you will put here the 2 at the place of x here in the numerator and also in the denominator, so you will get again an undefined value. Similarly my previous concept. Okay, so this is, in this way you will find out the domain of the function. But students, I have to also draw here the graph of this function. So how I will draw the graph, you can see now. And by this we also can find it out the domain and what? Range. So now students, I have taken here a function let fx is equal 1 upon x. Is it clear? Or we can write it in the terms of the Cartesian. This is equal, y is equal 1 upon x. Okay, so now I have to draw the graph of this function. This is y, and here x never will be equal 0. Okay, so now students, I have to draw the graph here. Is it clear? Any issue? Okay, so now students, y is equal what? 1 upon x. Here you can take all the values for the real numbers. This axis, it's a x axis. This axis represent what? It's a real axis and it represent the values of the domain. And this axis what represent? It is y axis and it's also represent what? Codomain. Y is equal, you can write here the y is equal f of x. Okay, this line gives you also the domain. Okay, so now I'm doing here, it's a 1 minus 1, it's a minus 2, minus 3, and here is minus 4. Similarly plus 1, plus 2. Let me check my camera is covering this portion. Yes, no issue with the camera. So now it's a plus 3, and now last is, here is what? Plus 4. Okay, it's a positive x-axis and it's a origin. And now it is, I have to take the plus 1. Here is what? Plus 1. It's a plus 2. And here is plus 3. And the last is plus 4. And negative here is what? Negative 1, negative 2, negative 3. And the last is negative 4. So finally students, see here, this axis OX, this is called the positive direction of x-axis, this is negative direction of x-axis, it is called OX dash, and it is OY, and here is OY dash. Okay, I have to make here the graph. of this function y is equal 1 upon x. Okay, so now students, make a table here, make a table. One by one we will put here the values of x. But students, tell me here, domain we can directly find out here. For the domain of this function, listen, what is the domain of this function? We can directly find out. See here, I will find it out, the domain of this function. Domain is what? Here domain is what? We can, here x never will be equal 0 here, because it is a rational function. It is a rational function, so x does not equal 0, means we can put all the real numbers, but what we cannot put? We cannot put 0. So this is known as a domain of this function. Is it clear? So students, it is clear that you cannot put 0 at the place of x because of the definition of the rational function. Okay, so because the denominator never will be equal 0 here, so this is because of this, the domain is real numbers minus 0. So here is, I have taken, actually I will increase this box here, I will take many digits. So tell me students one thing, here you cannot write what? 1, you cannot write 0, sorry. So one by one, actually I am writing here 1. I will start with the minus 4, okay, minus 2, is it clear, minus 1, 1, 2, 3, 4, okay. So tell me, when x is minus 4, x is minus 4, so y is what? When x is minus 4, so y is what? Y is minus 1 upon 4, y is what? Minus 1 upon 4. And if x is minus 2, so what is the value of y? Y is minus 1 upon 2. When x is minus 1, so what is the value of y? Y is minus 1. When x is 1, so it is also 1. When x is 2, so the y is 1 upon 2. And I will not put here the 3, sorry, it's a 4. So it will give you what? It will give you 1 upon 4. Is it clear, students? Any issue? Okay. So students, tell me one thing, what is the value of 1 upon 4? 1 upon 4 means it is 0.25. 0.25. Solve this portion. 1 upon 4. It's a 4.042 ja. Oh, 0.25. It's a 4 2 ja 8. It's a 2, and now 0. So it will give you 0.25. 0.25 is what? This is the value of 1 upon 4. So students, 1 upon 4 or minus 1 upon 4 is what? Minus 0.25. Okay. So now, one by one, at first we are going to take the positive value. 4, x is 4. If this distance is 4 units, so what is the, if x is 4, so y is what? Y is 1 upon 4, means y give you what? 1 upon 4. And where is 1 upon 4? Students, it's the total distance from 0 to this point. Suppose this point is a, it is plus 1. So what is 0.25? It is less than 0.5, means here you can write, it's a what? It's a 0.25. This will give you 0.25. Is it clear? So now this, if you are locating the point, so the point will be located at this place. Suppose this is a point P. Okay, what are the coordinates of this point? At first we will write the distance of the x-axis, whatever we have covering. It's a 4, and y is what? 1 upon 4. So I have located here the point P. Point P is what? 4 is what? 4 is called a perpendicular distance of y-axis measured along x-axis. Okay, so this is 4, and again, what is 1 upon 4? 1 upon 4 is a perpendicular distance of x-axis. Perpendicular distance of x-axis measured along y-axis. So in this way you will find out the first point I have located here, and the next is what? Next, similarly we will locate what? Minus 4. Similarly, this will, here is it's a 0 minus 1, and here is what? 0.5. It's a minus 0.5, and it is what? Minus this point give you what? Minus 0.25. So here is what? Here is another, in this point it's a minus 4. So what are the coordinate of this point? This will give you P dash. Okay, and what are the coordinate? It's a minus 4 comma minus 1 upon 4, because y is minus 1 upon 4. Is it clear? So next is what? Next is when I have taken x is equal 1, so y is also 1. So in the, here is the point. What are the coordinates? 1 comma 1. Is it clear? So next is minus 1 comma minus 1. So if it is x is equal minus 1, here covering, and it is also minus 1. In this way we will get the value. What are the coordinates? Minus 1, it's a point, suppose O, so sorry, it's a Q, so it is also Q dash. What are the coordinates? Minus 1 comma minus 1. Okay, now students, next is what? Minus 2. If x is equal, sorry, I will take the positive at first. So x is equal to, so y is 1 upon 2. If you are taking x is equal to, here is x is equal to, so y is what? 1 upon 2. 1 upon 2 is 0.5. So 0.5 is located at this point. So what are the coordinates? 1 upon 2 comma 2 comma 1 upon 2. We will represent all the points by ordered pair, 2 comma 1 upon 2, because x, the total distance from the x-axis, this is 2, and from the y-axis it is 1 upon 2. Okay, so this is point, suppose I have taken r. So similarly the r dash will be where will be r dash? R dash will be, it's a minus 2 comma minus 1 upon 2. Minus 2 is what? Where is minus 2? Here is minus 2. Here is minus 2, and next is what? 0.5. so this will give you, it's what are the coordinate of, suppose this is point r dash, okay, and the coordinate of this point is what? Minus 2 comma minus 1 upon 2. Okay, now students, locate your points are very important, this thing. So minus 2 complete, minus 1 complete, okay, 1 complete, 2. Now students, if you are taking, suppose if you are taking plus x is equal 4, so y is also 1 upon 4. Okay, there is no issue. Minus 4 we have already located, minus 2 we have already located, minus 1 we are also located here. Next is 1, 2, minus 4, positive, this is also 1. Now students, we also take some points more. If x is, suppose if x is 3, if x is 3, so tell me what is the value of y? Y is 1 upon 3. Okay, and where you will locate? You will locate, it will be, no, ignore it. Okay, don't do it. Actually here, so finally I'm going to rough these portions, these coordinates. Okay, but point I will not remove. See here, very easily. Okay, because I need to draw here only the graph. I no need to define here. Actually neatness is very important. In this way, and it is also, I have to locate, of course I have to locate here the point, but I want to see the point. So in this way, here this will move in this way, but never it will touch the axis. It will never touch the negative direction of x-axis, and it will also never touch the negative direction of y-axis in this way. And similarly this will move on this way, in this way. So this is finally the hyperbola. Okay, you will get, and this curve never touch the positive direction of x-axis or positive direction of y-axis. Is it clear, students? If you are taking y is equal 4, if you are taking y is equal 4, listen, if you are taking y is equal 4, so what is the value of x? What is the value of x? X will be 1 upon 4. Very easy. X will be 1 upon 4. So where is the point? 4, x is 1 upon 4. Where is 1 upon 4? Here is 1 upon 4. 1 upon 4 means 0.25. So it's a 0.5 here. You will get the 0.25, and 4 is what? Here at this point. This point. What are the coordinates of this point? This will be give you x is what? 1 upon 4 and y is 4 in this way. Is it clear? Similarly, if you want to put x is equal, suppose I am putting x is equal minus 4, x is equal minus 4. Is it clear? If I am putting x is equal minus 4, so by is already, listen, if you are putting x is equal minus 1 upon 4, if you are putting x is equal minus 1 upon 4, listen students, if you are putting here by is equal, I am putting x is what? Minus 1 upon 4, minus 1 upon 4. So what is the value of by? I am putting here, so by is what? What is the value of by? So this will give you using cross multiplication. By is what? You can write the by is minus 4. Okay, so by is what? Minus 4. Is it clear? If x is minus 1 upon 4, put here minus 1 upon 4, so by is what? Minus 4. So now students, I am again locating this point, x is minus 1 upon 4, so this is, it's a minus, what is minus 1 upon 4 means? Minus 0.25. So this is a point which shows the distance what? Minus 1 upon 4 and minus 1 upon 4. So by is what? Minus 4. So in this way, minus 4 is from here, in this way. So what are the coordinate of this point? This point give you what? X is minus 1 upon 4 and by is minus 4. Is it clear? This is the graph and you are getting what? You are getting a hyperbola. Is it clear? Okay students, you will get the graph in this way. Okay, finally this portion has been over and listen. So now students, now I am going to discuss on the range of this function. Function is what? By is equal 1 upon x. So domain is we have already find it out. It's a real number minus except 0. It is a domain of the function, real numbers minus 0. So because here in this domain, set of values of x for which the function is not defined, here the function is not defined for only 0. Function is defined for all the values but not for the 0. Okay, so because of this, the set of values of x give you the domain of the function. Now I am going to talk about the range of the function. What is the range of the function? Set of values of x. Set of values of x, the function is defined, so the set of fx give you the range of this function. So the set of values of fx, so this is what? So by is equal already fx. So here you are getting all the real numbers but what? Not 0. So because of this, the range is all the real numbers except 0. Okay, this way you will get the range of this function. Here you can see from the graph, here the value never you touch this graph, never touch the origin. Okay, and it will move from the minus 1 and it is also from 1. Okay, so because of this, here all the values of the real numbers you can locate here but not 0 cannot see. You cannot see here the 0. Because of this, range is real numbers minus 0. Thank you students, and ready for the tomorrow lectures. It will be related from modulus function, and after that we will I will explain the signum function and then greatest integer function. Okay, so enjoy, take care and subscribe it and like. Thank you.